3. The fiber optic endoscope. To examine the stomach of a patient, a fiber optic endoscope is inserted through the mouth and runs along the esophagus. To suppress the reflex action of the patient and make the process less uncomfortable, an anesthetic spray is often applied. A. Structure of a fiber optic endoscope. The fiber optic endoscope is divided into 3 different parts, namely the handle, the bending tube section, and the endoscope support system. Let's check the following video, which will show you the operation of a fiber optic endoscope.
An endoscope consists of an optical fiber cable with a small light source and a video camera at one end. The cable is flexible and can be inserted into the human body to enable the doctor to examine internal organs. The endoscope is inserted through the mouth into the patient's stomach. It first passes through the throat and the esophagus. The endoscope then enters the stomach. It can be bent to examine different parts of the stomach. A cable with a hook at one end can be inserted through the endoscope into the stomach to take samples of the bad tissues of an ulcer for examination.
B. How a fiber optic endoscope works. First, the light from the support system is transmitted by the incoherent bundle to illuminate the cavity inside the patient's body. The cavity reflects light by diffuse reflection. The objective lens on the tip of the bending section forms a real image of the cavity, and the image is transmitted by the coherent bundle to the outside end. An eyepiece at the outside end may then magnify the transmitted image for examination and diagnosis. Note that the final image may not be an exact copy of the object, as each fiber may not map to a single color pixel of the object. And you may have noticed that thinner fibers are better because it produces higher resolution, and the endoscope may bend more. It also ensures total internal reflection to occur more easily. In addition, there are other channels in the endoscope for water, air, and even tools like biopsy forceps, which may extract live tissues from patient body for further examination. Exam link 2. Image transmitted by coherent and incoherent bundle fibers. Fibers are thin, very thin. It is either illuminated or not at all. Coherent bundle fiber can preserve the image, while incoherent bundle fiber cannot. For a bundle of constant diameter, with more fibers which are thinner, the brightness of the image does not change much, but the bundle can be bent more. More importantly, the resolution of the transmitted image can be increased, and a higher quality of image may result, which may then give finer details of the organ's structure, and therefore more structural information. Try checkpoint 7 on the next page.